Okay, so question number 8. Aluminum carbonate, Al2CO33, is used in fire extinguishers since it decomposes when mixed with water and releases carbon dioxide, which prevents combustion. That's interesting. So A, what is the percentage composition of aluminum carbonate? Okay, so to answer this question, we would need all of the individual atomic masses of the atoms involved in aluminum carbonate. So we can look their values up on the periodic table. So I don't know aluminums off the top of my head. So if we looked up the molar mass of aluminum, it's around 26.98 grams per mole. And we also need the molar mass of carbon and oxygen. So the molar mass of carbon is 12.01 grams per mole, and the molar mass of oxygen is around 16 grams per mole. And we also need the total molar mass of aluminum carbonate. So let's write that down on the right side here. So when finding the molar mass of a compound, we need to take into account how many of each atom there is in the compound. So we have 2 atoms of aluminum, so it's going to be 2 times the molar mass of aluminum plus 3 times the molar mass of carbon plus 3 times 3 for the oxygens. So we have 9 times the molar mass of oxygen. And now we just need to plug in all the values that we found from the periodic table. Aluminum's was 26.98, carbon's is 12.01, and oxygen is 16. So the total molar mass of the entire compound is 233.99 grams per mole. Okay, so now we have all the individual atomic masses for our elements, and we also have the total molar mass of aluminum carbonate. So now when finding the percent composition, we need to take into account all of the elements and also how much of each element there is in aluminum carbonate. So for example, let's calculate the percent composition of aluminum. So we have 2 atoms of aluminum in aluminum carbonate, and we also know the molar mass of aluminum is 26.98 grams per mole. So now we just divide this by the total molar mass, which we found to be was 23.99. So we get a percent composition of around 23.1%. And this is for aluminum. So now let's look up the percentage of carbon. So there are 3 atoms of carbon. Carbon's molar mass is 12.01 grams per mole. And again, the total molar mass is 233.99. Oh, forgot to add that we need to multiply by 100, obviously get the percentage. So all of this multiplied by 100 gives us a percent composition of around 15.4% of carbon. And now let's calculate the percentage of oxygen. So there are 9 oxygen atoms, and the molar mass of oxygen is 16. And then we divide by the total molar mass, which is 233.99. And let's not forget to multiply by 100% to convert this decimal into a percentage. And we get 61.5% of this aluminum carbonate is oxygen. So now we can double check to see if all of these percentages add up. So aluminum carbonate is 23.1% aluminum, 15.4% carbon, and 61.5% oxygen. So let's double check to see if we did it correctly by adding up all these percentages. And we get 100%, which is good. Okay, so now let's see what the junior tutor said. The percent composition is the percentage of each element that is in the compound, and to find the percent composition, we first have to find the molecular weight of the compound and then relate the molar mass of an element to the molecular weight. The molecular weight of a compound is equal to the sum of the molecular weights of the atoms that are in the compound. So for aluminum carbonate, we have 2 times the molar mass of aluminum plus 3 times the molar mass of carbon plus 9 times the molar mass of oxygen to give 233.99 grams per mole. So they have the percent composition of aluminum equal to around 23, carbons is around 15, and oxygens is around 62. Okay, so this solution is correct. Okay, so those are all the questions for this session. And if you enjoyed today's Q&A and you'd like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you'd like to submit a question of your own, then check out the links in the description. Also, if you enjoyed today's video, you can give it a thumbs up or a comment and share with your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.